The chemical synapse is discussed in this screencast. This topic may be found in Chapter 7 of your textbook. This screencast was designed to achieve the following objectives: describe a chemical synapse, explain how a neuron communicates with the receiving cell at a chemical synapse. In the previous screencast, you learned how nerve impulses are generated by a neuron. Now we examine how the generation of a nerve impulse in a neuron is communicated to a receiving cell. Nerve impulses are not electrically transmitted from a neuron to a receiving cell. Instead, the communication is achieved by the release of a chemical called a neurotransmitter by the sending neuron at what is called a chemical synapse. A synapse is a junction between a neuron and a receiving cell. In this example shown on your screen, we have two neurons that form a synapse. At the top of the screen, we have the transmitting or sending neuron, and at the bottom, we have the receiving neuron. And the synapse is between the axon terminal of the transmitting neuron and the dendrite of the receiving neuron. If we were to take a closer look, we'd see that at this synapse, the two cells don't actually touch. The axon terminal does not touch the plasma membrane of the dendrite. There's a little space between the two cells, and this space is filled with extracellular fluid, and it is called the synaptic cleft. So, what's occurring at this synapse? Well, we have an action potential that's moving down the axon of the transmitting neuron, and it's illustrated by the little squiggly red line. Once the action potential enters the axon terminal, it causes vesicles that contain neurotransmitters to merge with the plasma membrane of the axon and dump their contents into the synaptic cleft. Because the vesicles are dumping a molecule or chemical into the synaptic cleft, this synapse is referred to as a chemical synapse. Let's look closer at what's occurring in this chemical synapse. So, an action potential has entered the axon terminal, causing vesicles containing neurotransmitters to merge with the plasma membrane and to dump their contents into the synaptic cleft via exocytosis. The neurotransmitter is now going to diffuse through the synaptic cleft, eventually binding receptors on the plasma membrane of the dendrite of the receiving neuron. Once the neurotransmitter binds to those receptors are attached to ion channels, and that will cause those ion channels to open. In this particular example, a sodium ion channel. This will cause a local depolarization in the dendrite of the receiving cell. If enough neurotransmitters bind enough receptors, the local depolarization will be of a sufficient magnitude to cause a depolarization to spread into the axon hillock of the receiving neuron, causing the production of an action potential in that receiving neuron. Note that the neurotransmitter binds the receptor for only a brief period of time, as it is quickly broken down by enzymes. So, to summarize what occurs at a chemical synapse, an action potential moves down the axon into the axon terminal of the sending neuron. This causes vesicles containing neurotransmitter to merge with the plasma membrane and to dump their contents via exocytosis into the synaptic cleft. In the synaptic cleft, the neurotransmitter diffuses through the extracellular fluid and binds to receptors on the plasma membrane of the receiving neuron. This causes sodium channels, in this particular example, to open. As sodium ions move into the intracellular fluid, they cause a local depolarization, which, if strong enough, can eventually cause an action potential to be generated in the axon hillock of the receiving neuron. The neurotransmitter only binds for a short period of time, as it is quickly broken down by an enzyme. Let's now review the objectives of this screencast. Describe a chemical synapse. Explain how a neuron communicates with a receiving cell at a chemical synapse. Reflexes is the topic of the next and final screencast.